It's Professor Dave. Let's work with functions.
He knows a lot about all kinds of stuff. Professor Dave explains.
We just learned what functions are and how to evaluate them. But things can get a little trickier than this. What if we want to plug in an algebraic term rather than a number? For example, let's say we have f of x equals 2x plus 1. What is f of x plus 3? This works the same way as plugging in a number. We just put x plus 3 everywhere that we see x. 2 times quantity x plus 3 is 2x plus 6, plus the 1, and we get 2x plus 7. We may also want to do algebra with 2 or more different functions, so we need to know how to add, subtract, multiply, and divide functions. Let's say f of x is 2x plus 1, and g of x is x minus 5. We could do f plus g of x. That's the same as f of x plus g of x, which is 2x plus 1 plus x minus 5. Combining like terms, we get 3x minus 4. We could do f minus g of x, which is f of x minus g of x, or 2x plus 1 minus the quantity x minus 5. Don't forget to distribute this minus sign, which inverts the signs of these terms, giving us 2x plus 1 minus x plus 5, which becomes x plus 6. If we did g minus f, we would get a totally different answer. We can also do f times g of x, which is f of x times g of x. That would give us the product of two binomials, which we could FOIL. We've already covered this method in detail, so hopefully we can do this quite easily to get 2x squared minus 10x plus x minus 5, which we can then simplify by combining the x terms. And lastly, we can do f over g of x, which is f of x over g of x. In this case, we just put 2x plus 1 over x minus 5, and that's all we can do. We should note that the domains of both f of x and g of x are all real numbers, and that domain does not change for any of the above manipulations, except for the division we just did. Because with x minus 5 in the denominator, x can no longer be equal to 5. We could also evaluate composite functions. This is when we do something like f of g of x. We will either denote this with a little open circle, or a little more logically, we can put g of x where x goes in f of x. This is different than f times g, because we are plugging g into the function f. We are using the output of g as the input of f. In other words, we are taking f of x minus 5. We plug in x minus 5 for x, multiply through by 2, and add 1 to get 2x minus 9. We can also find g of f of x, and it will be totally different. We put 2x plus 1 in for x in the g of x expression, and all we need to do is then subtract 5 to get 2x minus 4. But it doesn't end here. We could do f of x and g of x if we wanted. This is not the same thing as squaring the function, which we can also do. F of x would mean plugging in 2x plus 1 where x goes, and that means multiplying through by 2 and then adding 1 to get 4x plus 3. We could do f of x, or g of x, or any sequence you can imagine, using 2 or even more functions. Now that we know how to work with functions, let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.